Welcome back, mathematicians. We're now dealing with more complex squares and cubes and square roots and cube roots. This is found on page 87 of the textbook. We're going to move straight into worked examples. Remember, we have one term here, but we have brackets. So again, we are going to look at the laws of bed mass. So I'm going to deal with the bracket first. That's what I'm looking at. Right, and we're just going to copy down the rest of the terms as they appear. So that will be negative 2. I'm dealing with this bracket. When I raise a power to a further power, every factor must be raised to that power. Right, 1 multiplied by 2 is 2, so that's 3 squared. 1 multiplied by 2 is 2 over 6a. Right, so let's simplify 3 squared. You can simplify it in the first step. You needn't do the step that I did first, but I just wanted to show you what to do. So that's negative 2. 3 squared means 3 multiplied by 3, which is 9a squared over 6a. Now I'm going to remove this bracket by distribution, but remember, all it means is negative 2 multiplied by 9a squared. So signs, numbers, variables, or letters. A negative times by a positive is negative. Numbers, 2 times 9 is 18, and I have a squared over 6a, which now means I'm doing division. So once again, we look at the signs, numbers, and letters. So first of all, a negative divided by a positive is negative. Now I deal with the numbers. 6 goes into 6 once. 6 into 18 goes 3 times. There are more a's at the top, so that cancels. And I say that will give me a. 2 minus 1 is 1, a to the 1, or just a. So I write this out, negative 3 times a, negative 3a over 1. You don't have to put over 1 if you can go straight to the answer, which is negative 3a. Right, so things you have to remember. The laws of bed mass. The next thing we had to remember, that the fraction line makes the numerator one term, and we continue by dividing brackets, and finally divide as shown in the previous section. Let's look at this. The root sign acts as a bracket which cannot be split. Remember what we said, you cannot split a root over a plus or a minus. So we cannot split this, so that means we have to simplify first. Right, so we're not working with the cube root, we're just going to copy it down, cube root. I check that these are like terms, x to the 6, y to the 9, x to the 6, y to the 9, so they belong to the same family. They are the x to the 6's, y to the 9. And now apply laws of integers. So if I've got negative 100, and I'm going to add 36, so I add 36, I would land up at negative 64. So this here is negative 64. Always check when you have a negative that it is a cube root, because a square root you cannot find the negative square root, that's non-real. So we've simplified the like terms under the root. Now we have one term, and now we're going to cube root using signs, numbers, and variables again. Signs, numbers, variables or letters. Right, the cube root of a negative is negative. The cube root of 64 is 4. Remember, when we cube root, we are grouping in groups of 3, so you're going to say x to the 6 divided by 3, y to the 9 divided by 3. So let's simplify that. Negative 4, x, 6 divided by 3 is 2, y, 9 divided by 3 is 3. Remember, this step you can leave out and go straight from the cube root to your answer. Okay, when cube rooting, the factors are grouped in threes. That's when we talk about the variables. Let's look at the test your understanding. The first thing I do, I always look inside the bracket to see if I can simplify anything. Remember, this here means multiply. So 2 dot doesn't mean 2,5 or 2.5, it means multiply. But now I'm not going to say 2 multiplied by 5 is 10 because I could simplify this. 5 goes into 5 once, 5 goes into 5 once. I have a y here and y squared there. Y goes into y once, and I say y 2 minus 1 will give me 1. I would like to rewrite that. Okay, so we have 2x cubed y over 1, and I'm going to cube that. Okay, which is the same as 2x cubed y to the power of 3. Now that's what we looked at in the previous exercise. When I raise a power to a further power, I write down the base and I say 1 multiplied by 3 is 3, x, 3 multiplied by 3 is 9, y, remember your invisible 1, 1 multiplied by 3 is 3, and 2 cubed is 2 times 2 times 2, which is 8, x to the 9, y cubed. That's the answer to that question. Let's look at our next one. This is a bit more complicated. Right, but remember the laws of bed mass. So I'm going to deal with my exponents first, my bracket first. I look inside the bracket. I do not see any like terms. In fact, there is only one term. So let's have a look. So when I have a power raised to another power, I write down the base and multiply exponents. P cubed, I'm not using at the moment, or I'm not simplifying, so it remains p cubed. Right, now I write down my base, which is p, and now I say 4 multiplied by 2 is 8. I write down my base, which is q. 4 multiplied by 3 is 12. And then I write down my r, and r to the power of 1. 4 multiplied by 1 is 4. Check, nothing can be simplified in the bracket. Now remember, this is distribution or simply multiplication. When I multiply powers with the same base, as a p and a p, I write down the base and I add the exponent. So I'm going to go 3 plus 8, q to the 12, and r to the 4. You could leave out this step and go straight into p. 3 plus 8 is 11, q to the 12, and r to the 4. That is the answer to that calculation. Let's look at this example. Remember that if I have a multiplication sign, I can split my square root. And in this case, I'm going to split the square root because I don't want to multiply 9 by 25. It's going to be easier for me to work it out separately. So what we're going to do is we're going to say 9a squared b to the 4. I'm going to square root that. Then I'm going to multiply it by the square root of 25 a to the 4 b to the 6. Right, so the first thing I'm going to do, remember, signs, numbers, letters, signs, numbers, variables, or letters. So all of these are positive, which I check, and I can only do the square root of a positive number. So the square root of 9 is 3. I write down my base, and remember, square root is in groups of 2, so I'm going to say 2 divided by 2. I'm going to say b, 4 divided by 2, square root. Then I'm going to multiply that by the square root of 25 is 5. I write down my base, 4 divided by 2, 2 for square root, b to the 6 divided by 2. Now remember, this step you can leave out. You can go straight to this answer, 3a. 2 divided by 2 is 1. Remember, invisible 1. b, 4 divided by 2 is 2. And I'm going to multiply that by 5. a, 4 divided by 2 is 2. b, 6 divided by 2 is 3. Now remember, I'm multiplying these terms together, so I do not look for like terms. All I do is I apply the laws of exponents. And once again, I've got to check my signs, numbers, and then my variables. So I've got a positive multiplied by positive is positive 3, multiplied by 5 is 15. When I multiply powers with the same base, I write my base down. 1 plus 2 is 3. I write my base down, which is b, and I say 2 plus 3 is 5. So the answer to that one is 15a cubed b to the 5. Let's look at the following example. This is even more complex, but I'm sure you'll know what to do. Right, I've put this one in so that you can have a look at this dot there. That actually means multiply. So what I'm going to do, I'm going to say 2, and I'm going to multiply it by, I'm going to find the cube root of that, the square root of that, and then I'm going to add them together. How many terms do I have? Well, this here is one term, and this here is one term. So this expression has two terms. Right, let's start with the first term. The cube root of 27 is 3. When I cube root, I take the exponent and I divide by the root. I'm going to take the exponent and I divide by the root, plus the square root of 36 is 6. Write down my base, and now I have 6 divided by 2 because it's the square root, n squared divided by 2 for square root. Right, now I can multiply these two together. 2 times 3 is 6. 9 over 3, well 3 goes into 9 3 times, n to the power of 1, or just n, plus 6. 6 divided by 2 is 3, so I've got m cubed, n to the power of 1. Always check your answer. I have two terms, but from this we can see that these are like terms because they have the same variables. Now we're going to apply the laws for adding and subtracting in algebra. So they are like terms. So I write down the family name, m cubed n, or I write down the variable, and now I'm going to apply the laws of integers. 6 plus 6 is 12. So the answer is 12 m cubed n. That's all for this session. I'd like you please to go and do exercise 6. 0.7. Thank you. Thank you.